All right, welcome back to our next set of notes. These notes, we're going to start talking about sequences. Okay, so we're going to learn this school year two different kinds of sequences, something called an arithmetic sequence and a geometric sequence. And the difference between the two is whether you're adding, subtracting, multiplying, dividing. But regardless, there are two different ways to write these sequences. So today what we're going to do is we're going to learn about an arithmetic sequence, and we're going to learn how to write them in something called recursive formula. So let's first write down the definition of an arithmetic sequence. This is a sequence in which the difference between any two, squeeze that in there, any two consecutive terms is constant. Okay. The common difference. This is the numerical difference. D, known as the letter D, between any two consecutive terms. So the first thing that we're going to do is we're going to determine whether the sequences are an arithmetic sequence. If yes, identify the common difference. Remember, for an arithmetic sequence, we need to see a constant change or a constant difference. So 1, 5, 9, 13. I would say yes, my common difference is an increase of 4. So let's go ahead and write down yes, my common difference is 4. Let's go ahead and go across to 2. We have a 1, 3, 5, 8. So it goes 2, 2, and then plus 3. So that's no, that is not a constant change. Let's go to number 3, 8, 6, 4, 2. This one is yes. We get a constant change, a decrease of 2. So my common difference is minus 2. For 4, negative 5, negative 8, negative 11, negative 14, we do have a common difference, okay? That is to subtract 3. So let's go ahead and write in yes. My common difference is going down by 3. We'll do 5 and 6 next time I see you in class, okay? So just double check on those. Let's go ahead and get to if you're given an arithmetic sequence, find the next 3 terms. Okay, so these 3 are arithmetic sequences. We just have to continue the pattern. So 9, 13, 17, 21. Hopefully you see the pattern for each of these is to add 4 each time. If we continue to add 4, we get 25. 25 plus 4 is 29. 29 plus 4 is 33. Then from 5 to 2, we subtract 3, subtract 3, subtract 3 each time. If I continue that pattern, I get negative 7. Negative 7 minus 3 is negative 10. Negative 10 minus 3 is negative 13. And we'll do number 9 next time I see you in class. So this was a little bit, this top part, talking about arithmetic sequences and what the common difference means. Now, the next part is to talk about a formula for writing an arithmetic sequence, okay? This first formula is called a recursive formula, and where each term in the sequence depends on the term that came before it, okay? So some other bits of notation. A sub 1 is the first term of the sequence. N is the nth term of the sequence, so N could be like 21 if we're finding the 21st term. N minus 1 is the previous term of the sequence, and then D is your common difference, okay? So we'll be creating formulas so they look similar to this one. Okay, so let's go ahead and try number 10. So number 10, to write the recursive formula, we have 12, 19, 26, 33, and 4. And notice the change between each one of these is we are adding 7 each time. Okay, so my common difference is to add 7 each time. When I write this, we're going to identify our first term. So our first term, a sub 1, is 12. Okay? My recursive formula, we don't know which term we're going to write, so we're going to leave it as a sub n equal to a n minus 1. That's the previous term in the sequence. Okay, we don't know what it is, so it's going to be n minus 1. And then my common difference was plus 7. Okay, let's go across to number 11 now. So for number 11, my initial term is negative 4, so we can even just start by writing that down. So from negative 4 to 5, 5 to 14, 14 to 23, you have to think about what is that common difference. The common difference each time is we're adding 9. So if I write in my recursive formula, again, matching that up, a sub n, a n minus 1, okay? If we knew what n is, then we would put that number in, but we'll see some examples of that, and then we're going to add on the common difference of plus 9, okay? And then we'll do 12 and 13 next time I see you in class. Okay, go ahead and flip it over. So mine is 2 pages. Coming here to now problem number 14, okay? Consider the sequence of numbers given by the following definition. Okay, so this time I'm giving you the first term of 7, so b sub 1, and b sub I, so instead of n, this one has an I. My common difference is 4. Okay? So what we're going to do is we're going to give a common sense interpretation for this recursive function rule. So kind of just what I said is how the list starts with 7. So let's write that down. So the list, so the sequence, the list starts at 7, and, okay, each term afterwards then 4 more is added. I'm not saying this right. Each term is added 4 more than the previous term. Okay. I don't know if added is the right grammatical correct term. I don't know if then would be better if we want to put in and make this then. I should have used my pencil today. Is then 4 more than the previous term? I don't know. Whatever you think is better is fine by me. All right, let's go ahead and do B, though. So for part B, it says write out the rule for the first 4 terms and evaluate each one of them except B sub 1, which is given, okay? So the way this is going to work, so this is actually now applying the recursive formula using it. So our first term, B sub 1, is given, so we're going to write that down as number 7. B sub 2, okay? My second term. So according to my definition, okay, to find the second term, b sub 2, 2 minus 1 is 1. So I'm going to have b1 plus 4. Okay, so again, I substituted that 2 in for I in that definition. Now, b sub 1 is 7. So it's going to be 7 plus 4 equals 11. Now let's try this again for b sub 3. b sub 3, again, in my formula, I put 3 in for I. 3 minus 1 is 2. So it's b sub 2. Then I drop down the 4 because it's a part of the formula. B sub 2 is 11. So I have 11 plus 4, again, part of the formula. Well, 11 plus 4 is 15. All right, and then it says first 4 terms, so let's go ahead and do the fourth one, B sub 4. Again, if I substitute 4 in for I minus, or 4 minus 1 is 3, B sub 3, drop down that plus 4. B sub 3 is 15. So I put 15 plus 4, and then we get 19. Okay, so that is how the recursive formula works. I know that some of you can see this without your mental math, but you do need to show work. These are the kind of questions where you need to be showing work. Those are the kind of questions that they'll ask. So when I talk about that common assessment and the end of course exam, they're going to be asking to identify the correct equation. So make sure you are showing work. That's it for these notes. So we're going to do 15 and 16 next time I see you in class. Okay? Over and out.